All right, welcome back, Algebra 2. It's Miss Castro again. So I wanted to show you a matching example for 9.6. There's quite a bit of matching on your assignment, and if you're using Desmos, it's actually very easy to do. A little time consuming, but definitely worth it if you're going to get the right answer. So here's a quick matching. So you've got 1, 2, 3, 4 different trig functions here. They all kind of look similar. They have a lot of 2's in them. And then you have these 4 graphs here to choose from. So really want to just show you guys strategy here. So we're going to go over to Desmos here in just a second. I'm going to have to flip back and forth between the screens so you guys can see stuff. Let's go ahead and type this first one in, sine 2x. So sine 2x is the first one we're going to type in. Let's cruise over to Desmos and type in sine. So come down here to the bottom, functions, sine. Now notice Desmos automatically puts the parentheses for you. So it was sine 2x. So the 2 and the x have to go inside, and then we have to make sure we close it off. You've got to make sure you close off that inside of the trig function. All right, so that's what we get. Now here's the thing. These all look like waves, so it's very confusing, especially if you're not paying attention to your axes, specifically your x-axis. So I'm going to cruise back real quick to the answer choices, and we're going to take a quick look at all the x-axes here. So take a look at the smallest and the highest x value. Every single one of these graphs goes from negative 2 pi to positive 2 pi. And so if we really want to get a good description or a good visual of how to match these graphs, we want to keep them on the same parameters. So let's do that. Let's change our x-axis so that we have it going from negative 2 pi to positive 2 pi. So to do that, we've got to go to graph settings. It's over here where this little wrench is. Click on that. Make sure you're in radians since looks like we're in radians for this. Come over here to the x-axis and let's change it out. Let's put 2 pi. So 2, got to bring up my key here. So 2 pi for your low part, and on the right side, you're going to do your positive 2 pi. So 2 pi for your high part there. All right. Now, that's not it. Now your graph is going to go from negative 2 pi to positive 2 pi, but we want it to display in radians. If you noticed, it had pi on the x-axis. Right now, I don't have any pi's because it's just estimating those decimals. Let's go ahead and change our step so that it just says pi. You could change this to whatever you want. You could do pi over 2, 2 pi, but let's just keep it simple and do pi. All right, so here we go. You can clearly see that our graph is going from negative 2 pi to positive 2 pi. The y-axis is not that bad. I mean, you might say, oh, what is this going up to? But you can see this is 2, so this must be 1 right here, right? If you want, you could like stretch out your graph or whatever, however you want. But I think it's pretty clear for you to see that. All right, so let's go ahead, let me minimize that just a tad more. Let's go ahead and go back to our graph and take a look at which one has this matching setup. So first off, this one starts at center. So this is a center, high, center, low, back to center. Look where the first cycle ended. It went from 0, 0 to pi, and that's the first cycle on a sine graph. So let's go back to our graphs and see which one matches that pattern. All right, so first of all, graph A does not even start at center, so it can't be A. B starts at center, so let's see if that does our center high, center low, center, and ends at pi. So center, high, center, low, back to center, and take a look at that. It does end at pi, so B looks like our graph. You might say, wait, what about C? It also starts at center, true, but watch where this one ends. Center, high, center, low, center. Look at the x value there. That ends at 2 pi, and that's not what our graph showed on Desmos. So this first graph is going to match to B since it ends at pi for the first cycle. So going back to Desmos, this one ends at pi, so this one is going to be matched to graph B. Just going to type a big fat B there. Nice thing is it actually takes it out of the equation too. So the first graph on the answer choices is going to match to B. Let's go ahead and go type in our second graph. Let me switch back to the questions. I don't remember what it said. All right, so the second graph here says 2 cosine x. So the 2 is out in front. So 2 cosine x. So typing that in, 2. By the way, you can also use your keyboard to type sine and cosine. So I'm just going to type cos here. The only thing is you have to insert your own parentheses when you use your keyboard. So this said 2 cosine, and it just had x on the inside. So let me type x and close it. So there's the second graph. Notice there's not as many waves on this one here, okay? And the other nice thing is we don't have to keep retyping the parameters since we already did it. So if we just continue typing in our answer choices, we have everything set. So take a look at this one. This one starts at a high. And not only that, look at the point. It's at 0, 2. So this goes high, center, low, center, high. And look where it ends. It ends at 2 pi. And this started on a high, so this is obviously our cosine graph. It started at 0, 2 for a high, and it ended its cycle at 2 pi. Let's go back to our graphs and see which one started on a high at 0, 2 and ended the cycle at 2 pi. All right, so this one starts on a high, but take a look at graph A. That's not 0, 2, that's actually 0, 1. So even though that might seem tempting, it's not the right graph. We know it's not B. Take a look at C. Does not start on a high, so it's not C. Hopefully it's D. So let's take a look here. Starts on a high at 0, 2. Let's see if it ends at 2 pi. High, center, low, center, high. It does end at a high, and it does end at 2 pi. So D matches to the second graph here. So this second graph here, the second equation matches to graph D. Nice, takes it out of the equation. All right, so we already got half of them done. Let's take a look at another one. So the third one here says 2 sine. So 2 sine x. So keep in mind 2 sine x. So let's come down here to the next line. 2 sine parenthesis x. All right. Make sure you close it off. Some of your problems on your Edgenuity are going to have multiple parentheses, so type in, if it shows 2 sets of parentheses, type the parentheses in, okay? Same thing. Main thing here is making sure that you adjust your settings so that you see a good picture of it and you're not guessing where the pi's are and stuff like that. They're already there. All right, so let's take a look at this one. This one starts at center. It's sine graph, so it makes sense that it starts at center. So this one's starting at 0, 0, center, high, center, low, center, and it ends at 2 pi. So starts at 0, 0, ends at 2 pi. Let's see which graph does that out of the remaining ones. We only have A and C left. So first of all, A does not start at center at all, so that's not it. So that leaves us with C. So it starts at center, center, high, center, low, center, and it does end at 2 pi. That means our third graph here is getting matched to graph C. So let me go ahead and put C here. And obviously the last one has to be A. Now I'm going to type in A just so you guys can see what A looks like on Desmos. So A says cosine 2x. And if you look at graph A, it's got quite a few cycles in a short amount of time here. So this has a much shorter period. So let's take a look at 2 cosine x. Also want to show you one last thing to adjust. So cosine parenthesis 2x, that was what this last one said. You can clearly see there's a lot of cycles going on here. So the first one goes high, center, low, center, high. So this one only takes a pi unit to do a whole cycle, so it's getting compressed horizontally for sure. All right, but here's the last thing I wanted to show you. Some of your examples on Edgenuity are not in radians, meaning they don't have all these pi units here. Some of them have degrees. That's fine. It works the same way, but you will have to come over to your settings and change that. So take a look here. Right now we're in radians because every single one of these had like some sort of pi x value, right? But some of your graphs might have degrees. You can click over here to where it says degrees, but notice when I hit degrees, this just gave me a straight line on my graph. That's because you have to go in and adjust your axes. So if we're talking degrees, now we're going from like negative 360 to a positive 360. Okay, so you have to go in and change that. Also your step, it's not going in terms of pi anymore. Maybe it's going in units of 180 or 90. So you need to go in and change those degree values if your problem's in degrees. So yes, pay attention to your problem because that's going to show you how to adjust it. But you can see now that I do have it in degree mode. And so you can kind of do the same thing. You can say, oh, at 0 degrees, it's at 1. And at 45 degrees, it's at 0. And so now you have your degree measurements here, okay? So again, Feel free to adjust. Depending on your question, you're going to have to, but please use Desmos for those matching graphs. It's very easy to do, but adjust your window. All right, good luck, Copper Canyon. And you have a test coming up next week, so good luck to you, and we'll have a tutoring session coming up soon. Bye.